website, the usual information. Now, if you want to find, when would that be? Tuesday's video, all Zoom videos are here. So if I click on that, here is our link that will last us all the way to May. And click on that, and there we are. So if you wonder where the videos from this class is, right, where I put all our Zoom meetings are there. I do a bit of editing, so I cut bits at the beginning off, so we won't be able to find out about your goblin cat, because I guess, not that I think you would mind if we kept it on, but I tend to keep these things off. And at the end, sometimes I cut them off, because if someone asks me a question, if it's useful, then I think the rest of you might want to hear the answer, I'll leave it on. But if it's, it's just something that that person needs to talk about, then I cut it off. You don't need, to hear other people's personal details. So that is where it is. Go with that. Let's get this show on the road then. We have a lot of stuff to do. And I think I will begin by giving you a big summary of all the formulas that we're going to be using today. And I've kind of organized, at least partly organized, what formulas get used where. And I'm going to, where is it? Hit this button. There we go. I'm getting some feedback. Sounds like a horn, at least in my ears. So you'll have to hit the space bar if you want to say anything now. So let's return back to where we were. So if you ever get a question that involves the word simple interest, and here's a big list of them at the top there. Questions 1, 2, 3, 20, and 24. You're going to use this formula and or this formula. So these are the formula that you use when the question has got something to do with simple interest. So if you see that word, simple interest, think about using these. And there are lots of different versions of these formulas, but they do get used quite a lot. And we're going to go through a number of questions today, a lot of questions, I hope, so we get plenty of practice. Similar to the homework, where we get to look at each of these things with plenty of practice, I hope. Right. Now, if you see a question and it mentions compound interest, question 8, 9, 13, and 14 do, then this is the formula that we're going to be using. Now, since this is a video, I don't think you should try and frantically write down this page, because you probably won't be able to finish it. Some people take pictures of it. I don't know if that helps. Or you might just wait and go and look at the video and, at your own time and leisure, write it down. Plus, we're going to be doing a lot of questions, so you can just wait until that happens if you prefer. But if you see compound interest, right? So compounded monthly, compounded daily, things like that, you might want to think about using this formula. If it says compounded continuously.
Is this the information you have in the notes as well? Like, I was just looking through them.
It's been updated. The updating is I've added now the questions from the homework that deal with that particular formula. So they're just a little bit different. If I move on, you're going to have our present value formulas. You're going to use this formula when you want to know how much money you need to start with in order for it to be worth in the future A. And that's a weird formula, and that's the one I've only got 23 there, so evidently there's not many of those. Although the next set of homework, which is called Interest Part B, is just more practice at the same stuff, right? They're just all jumbled up so you don't get into a bad habit of thinking every question is the same. And this formula here is time calculations. If you ever get a question and it involves compound interest, and at the same time it says, how long do you need to take to get this thing to happen? So the kind of question might be, I start with $1,000. I get 5% interest compounded monthly. How long will it take me before I've got $50,000 in the bank? So it's a kind of how long will it take me type of question, and it will also involve compound interest. So when you put those together, you're going to use this really weird looking formula, but essentially what it does is it tells you how long it will take for this amount of money to turn into that amount of money. And that is a kind of list of the major formulas that we're going to be using. So I thought what I would do is start with the first one, maybe find a couple of questions and do them, right? Homework questions, or at least similar to them. So let's start off, although we've covered this as well, I think it's good to go back and kind of do an overlap. Which one shall I start with first? Okay, this one here is similar to question 5 in homework part A, which is what all of them are going to be at the start. And you have to find the interest. And in this story, you start with $1,000. The interest rate is 8%. And the time is 4 years. So the only reason I'm picking this is it's a nice, simple, you don't really need to think much about it. And you're being asked to find the interest. So I know I'm going to use this formula. P, the amount of money you start with, is $1,000. R is the interest rate written as a decimal. And T is 4. So it's simply just going to be 1,000 times 0.08 times 4. And we got a calculator for that. So I'll just type that in, 1,000 times 0.08 times 4. And the answer is $320. And that's what you would stick in the box. Okay, so this is a question involving simple interest. Here's another question involving simple interest, but a little bit different. In this question, you end up with, and they will use the word future value. So you end up with $350. You started with $200. That's basically P. So I'm telling you, you're going to end up with 350. You're going to start with $200. And I'm going to tell you the simple interest is, what should we have? 2.5%. And the question is, how long will it take for this to happen? So the key here is it says simple interest. The minute it says simple interest, I write down this. In this question, I then very often write down what I know and what I'm trying to find out. Now, I know how much money I started with. It's $200. I know the interest rate is 2.5%, which has a decimal as that. T is what I'm going to find. How long will it take? Now, the only one that's missing right now, and I'm going to write it down, is the interest. But the interest is not $350. That's what I end up with. And the interest definitely isn't what I started with. don't I have to do a little calculation in my head to figure out how much interest I got? So if you started with $200 and in the future it's now worth 350, isn't the interest the extra that you've managed to create? And so in this case, you put in 150. So what I'm now going to do is use the simple interest formula, but I'm going to use it to calculate how much time it would take for $200 to turn into $350 at the very low interest rate of 2.5%, which is actually quite realistic right now. So you write down the formula, PRT. You write down everybody you know. That's 150. That's 200. That is 0.025. And the time I don't know, so I do T. What I typically do next is tidy up some things. Right, I can multiply these two together. So that's what I'm going to do. So 200 times 0.025, and I get 5T. And all I need to do now is figure out what T is, and the question's over, because T represents the time it would take. And this is where the algebra does kick in. So it's not like you don't get algebra, but you don't get it everywhere. What would I do to both sides to find T?
Divide 5 on both sides.
And there is a really depressing number. It'll take you 30 years. Today's interest rate is so low that most people aren't putting their money in the bank to retire. They're basically keeping their money in the bank because it's a convenience, isn't it? You know, your wages get paid straight into your bank. You don't need to fiddle around with checks. I guess cash is kind of dangerous if you have a lot of it on you, right? So it's more for security and ease that we're using it right now, because you're not going to make a lot of money at 2.5% a year. Would you agree it would take you forever and a day to try and build up any kind of retirement? So you might think, what are people doing? I mean, where are they putting their money? Well, it depends on your risk. If you think that next year or a couple of years from now, the economy is going to go slam dunk in a big hole in the ground because we've borrowed so much money that the inflation is going to kill us, you probably will keep your money in the bank just because at least it doesn't go down, right? It's still going to be there. But most people right now are investing retirement accounts, and they're investing in the stock exchange. Now, the stock exchange is very volatile. It's not like banks where you can never lose your money. You can lose money if you invest in the stock exchange, right? Because it goes down as well as up. And it's been going up for a while. The historical, and this is only historical, in the very, very long term, the average return on stock exchange is about 10% a year, which is pretty good. But you could pick some really bad stretches of 5 years and easily lose half your money. Right? So you end up with half the money you started with. You don't even make a profit. Right? Or you could, I guess, get lucky and pick a good stretch and double your money in 5 years. Right? But that's what we're doing, 30 years. Suppose I did a different calculation. And it could happen that the number for how many years it took came out as a rather clunky decimal. What WebAssign asks you to do very often here is to give the answer as years and whole number of days. And you might think, well, how can I turn 5.12 into years and whole numbers of days? So let me show you how you would do that. The 5 is easy. That's 5 years. So that would go into the first box. And then you would have so many days. You only use the decimal portion of your answer, in this case 0.12, and you multiply it by something, and that will give you how many days. What do you think you multiply the decimal 0.12 of a year by to find out how many days it is?
$365.
Yeah, we are going to pretend for the ease of calculations that every single year is 365 days. So don't worry about what about leap year, we're pretending they don't exist. So 0.12 times 365, and it's about 43.8. So to the nearest whole number, would you agree it's closer to 44 days than it is to 43? And that's how you do some of those answers. If you've done the homework and you're wondering, how does this turn into 5 years and 44 days? That's the method. Are we cool with that question? Right. So I want to do another simple interest rate question. Again, just playing about with the formula. So here's the story. I don't write all the words because it takes me too long, but I'll give you the gist of the story. You start with $4,200. What do you do? You invest it for 5 years. You get, at the end of 5 years, $600 interest. Now here's the question. What is the simple interest rate? So you might wonder what this investment is. It might be a bank, right? But if it is, it's probably only going to be about 2-3%. But you can invest in all sorts of other things. There are financial companies, for instance, that will invest your money in property. And if the property values go up, you know, that's where you're interested when you close it off in 5 years. Some of them do rentals. So you actually buy a piece of a property that's being rented and you get to keep that piece of the rent. So like if you put in enough money to own 20% of a property and it's being rented, you get the 20% of the rent minus your repair costs and taxes and all the other good stuff. So that's kind of a different way to invest. So I know it's simple interest because that word, or those words. So I'm going to start off with my same guy. Now, in this case, I didn't need to calculate the interest. It was just handed to me in a plate. I know how much you start with, so it's 4,200. I guess I should put in red who these guys are. There's P. There's R. There's T. Okay. So we've got P, got it done, times R, times 5 years. And we have 600. I multiply these two numbers together, and that's, I think it's 21,000, but let me double check. 4,200 times 5. Oh. Is there a kind of deja vu happening here? Don't you end up with having to divide both sides at the end to find the missing thing? So in this case, 600 divided by 21,000. And when I take 600 and I divide it by 21,000, I get the answer 0.0 to, let's round it off to say 3 decimal places, so 0.29. I know that is the correct answer, but isn't that the interest rate as a decimal? But don't you normally tell people interest rate as a percentage? So that is 2.9%. Okay, it's a little bit better than what a bank would give you, but it's not actually great, is it? Right, 2.5%. But you got your answer. Are we cool with the different versions of the interest rate question? Essentially, there are 4 different things here, right? I, P, R, and T. And each story will have 3 things told and 1 thing you're trying to find. So sometimes you're trying to find the time, sometimes it's the interest rate, sometimes it's the money you start with, and sometimes it's the interest. As long as they tell me 3 out of the 4, can I always find the 4th thing, right? The missing one. And so you just have to read the story and look out for simple interest. Because the minute you see that, kind of write that down first and then read the rest of the story, right? Are we cool? Right. So what I think I should do now is look at some homework questions and see what I can figure out. Oh, I got a list. I'm picking question 11 because it's in front of me. In question 11, find the present value. So they're asking you to find P, find the present value. And it says that you have to achieve $5,000 in 3 years and 4.5% simple interest. So interest is P or T. We want to achieve 5,000. That's their way. I've lost the question here. Ooh, I almost did a no-no there. So that's not going to happen. Yes. I just get confused by the achieve. It was 5,000. P, interest rate, 5%, time, 3 years. I'm just going back to my screen here, clicking some in. And this is question 11. Make sure I get it up and running before I screw up. Okay. $5,000. These 2 can get multiplied together. So that's going to be 0.045 multiplied by 3. And the answer I have is 0.135. So to get P, you take 5,000 and you divide it by 0.135. And we have and 4 cents. Now, if I read this question correctly, I would need to have that amount of money to get that interest in 3 years with that interest rate. Right. So that's how I'm reading that question. Pick another one. 19. Oh. 19 in my question says, suppose you see a car advertised for $15,000 and you're going to pay $410.83 a month. And you're going to do it for 4 years. And the question here says, what amount of interest are you going to pay? And I have just realized that this question doesn't need this formula. I say, why? If you take this information here, aren't you going to be paying in total 4 years, 12 times a year, each one of those payments, 410 and 83. So by the time I've paid off this car, it's going to be 4 times 12 times 410 and 83. And that ends up being $19,719.84. That's how much the car would have cost me if I just went in with money and bought it and drove right up. The interest is the difference between what the car is, would have cost and what you paid for it, right? So the interest is what you paid, take away what it would cost. And so if I take 19,719 and 84, take away 15,000, we are left with 4,719 and 84 cents. And it's the correct answer. I guess the moral of that story is that not every single question necessarily uses that formula. So be on the lookout in case there's another one in that list I gave you where you didn't need to use this formula. Would you agree this one is like a one-off question? I just figured that out, given the information. I'll get some in chat. Oh, we've got that. That's for later. Okay. What we got? 20 and 24. Ooh. I'm going to do question 20. You might wonder what that is about. Well, I know what that is about because I've already done this myself, just because I wanted to. Suppose you're buying a home and the sale price is 285,000, right? Pretty realistic number. And you pay a mortgage, and the mortgage that you're going to pay is $2,243.17 a month. And it's a 30-year mortgage. We are being asked in this question how much interest you've paid. It's just like the car question we finished a minute ago. So shouldn't I be able to find out the total amount of money I'm going to pay over that 30-year period? And then I'll compare it against what the house was worth. So if I just had money, I could buy it for that. And then I'm getting it off the bank, so I'm going to have to pay them back. And I'm going to calculate that. And what's it all about? The sad news is, wait till you see how big this number is. It'll scare you. Trust me, it'll scare you. Let's find out what the total is then. $2,243.17. 12 monthly payments over a 30-year period. Does that make sense that that's the total amount of money you end up paying? Here we go. $2,243.17 times 12 times 30. $807,541.20. Can you see where my wow came from when I looked at that question? Because I did it. I did it basically. I know what my mortgage is, and I did it, and I went, wow, that's what I'm going to end up paying. Now, how much interest is that? Well, it's what you paid, right? Take away what it would have cost if you just bought it right off. So you take $807,541.20 and you subtract $285,000 from it. So I've already got the big number in my calculator, so I can just take away $285,000, and I end up paying, or if this was me, an extra $500,000. And that is not unreasonable. That is very realistic at today's interest rates, which are very, very low, by the way. It's still pretty realistic. So I guess the question might be, why would anybody in their right mind buy a house with a mortgage if you end up having to pay that much interest, right? That's the total amount, but how that much interest? Okay, nothing to do with directly math, but it's connected to this. Why do people do it? There are a couple of good reasons I know. Maybe you'll come up with ones I can't think of. Hit spacebar. Got an idea? Why do people do it?
Because they can't get enough money by the time they have to get a house to just straight up pay for one, even though it's technically cheaper. Even renting would be more expensive in the long run, in most cases here.
Well done. In most cases. Do you know if you rent, and let's say your rent for the same house, I'll make up a number. Let's say your rent was half that amount, right? Isn't unreasonable, right? Half that amount. You know, if you rent for 30 years, at the end of 30 years, you don't have a house, do you? So can you end up spending 300 or 400,000 in rent? And at the end of it, have nothing. So that's one reason, right? You got to live somewhere, right? You're either going to mortgage or you're going to pay rent. Agreed? Hopefully, yes. You have those options. Can you see why superficially that looks like a bad idea, but it could be a good idea in the long run? There's a second one that's less obvious why they do it. That's the obvious one. I would agree with you. That's the one that came to my mind. You know, a little bit harder to think about. You know, that's what the house cost right now. What do you think that house is going to be worth 30 years from now if you look after it?
It goes down.
Isn't it going to be worth? It doesn't actually.
Well, if you take care of it, well, it'll go up.
If you take care of it, it will. If you don't take care
or
of it, you know, you're turning into a wreck and you'll get nothing. Right. Most houses will increase in value, especially if you look after, right? Fix the roof, change the roof, you know, do the wiring, whatever it is. That's an expense. Here's a story for you. If any of you have, say, grandparents, and they owned their house, right? They got a mortgage for it. Wouldn't their house, when they got it, maybe only $50,000? That's what it cost them, because it was 50 years ago. Isn't that same house today probably worth 300,000? Do you know what a house in California cost you 30 years ago?
No.
Do you know what a house would cost you today? much less. So the second thing is that although that number there is extremely big, the house value might not be as much as that, but it'll be darn close to it. It might be $500,000 the house will cost you, right? It'll have increased in value. So people do mortgages because in the long term, it's actually a better way to invest your money. You're living in a place so you don't pay rent, right? You're paying a mortgage, but you don't pay rent. Plus you're in a thing, a house, that if you look after it, will increase in value. So that when you come to retire and you downsize, with a bit of luck at least, your mortgage is paid, you have $500,000 to play with, and you can go to Vegas and blow it all on the roulette table, or whatever you do when you retire. So it's a while until you kind of look at the details. So, and that's what I'm telling myself when I think of the mortgage I'm paying right now. So if any of you are thinking of mortgage, here's my financial advice, which I'm not being paid for, so totally ignore it. But if you can, try and get a house right now. The interest rate is ridiculously low. It will never probably hit this low again in my lifetime, at least. I don't know how long it's going to stay this low, maybe for the next 2-3 years. Probably not that much longer. And if you get a house right now, the mortgage that you pay will be really low compared to what it will be in 5 years from now. So if you know you're going to stay here, right, you're not going to bugger off to California next year. If you know you're going to stay here and you know you've got some finances together, I would strongly suggest that you do get your house. That would be a very good investment, in my opinion. So I'm going to finish with 24. And this is John wants to retire. This is a silly question, right? But anyway, John wants to retire. He wants to retire on $10,000 a month. That's pretty impressive. That's a lot of money. And he wants to do that on his monthly income, right? And he's going to invest it, this unknown amount of money, and he's going to get 10% per year. So how much does he need? And they describe it as, try to get the question, make sure I'm scanning the right one. How much does he need? So the interest, because it's a simple interest question, is that. That number is actually per month. So I really need to figure out what it is a year, because we tend to calculate interest as a unit of 1 year. So it's 10,000 times 12. And so this interest here will have to be 120,000. We have to know how much does he need to start with. That's them saying find P. I know the interest rate is 10%, and technically we could call it 1 year, right? So he has to put money, he wants to know how much money do I need so that if I just live off the interest, that's how people phrase it. I'm going to live off my interest. I wish I could say that, right? That's how much interest he needs to get, an unknown amount of money, 10%, 1 year. If you divide both sides by 0.1, he would have to be a millionaire. He'd have to have $1,200,000 to live off the interest. It ain't happening, not with me. Right? That's a lot of money, isn't it? So if you are thinking about, and you should, I guess, think about retiring, do you see that it requires a lot of money when you stop working, right? When you stop making a wage. Now, what you'll get to live off will typically be your Social Security payment plus your pension. And most pensions now are hard to come by. I'm very, very lucky. I have a pension scheme with the college. And essentially what happens is that 10% of my salary goes into an investment thing. And the college pays 10%. So essentially 20% of my salary goes into a stock investment scheme. And so that when I retire in about 4.5 years from now, I certainly won't have that kind of money, but I will have a fair chunk of money, hopefully. And so when I retire, me and my wife retire, it will be our Social Security plus probably whatever this calculation comes out to be. But it requires a scary amount of money. I've seen articles that says you need to have about $1 million in assets when you retire if you want to keep the standard of living that you're typically used to when you retire, right? So you need to basically be a millionaire to retire. And that seems very unlikely right now because you're young. But trust me, if you invest and you have a pension scheme, it's not impossible, right?
Can I add something?
Yes.
So I know that something my family's big on saving and everything,
Right.
and all of this stuff. And something that I've grown up being told is that the second you turn 18, essentially, is you start putting about $20 every month into a savings, and you're supposed to, by the time you retire, you're supposed to have about $1 million or whatever, depending on how much you put in.
Do you know, hold those numbers, because we are going to do compound interest. And after that, we're going to do annuities. And when we come to do annuities, that's exactly what that's about. Basically, you just put a reasonable amount of money. $20 sounds a bit small, but I won't argue with that. We'll do the calculation. We'll find out if it's true, right? Because I think if you put it in 18, you could safely say that would be for 50 years, right? You probably say you retire at 68. So I think 50 years could be true, and we'll show you how it is. So yeah, if you don't have an investment, if your company doesn't work for, put a little away, put it in long-term savings, and just never touch it. That's the trick. Never touch it. And if you can do that, it can turn into that magic million that you need to retire, and not worry about paying the gas or the electricity anymore. So is there any more questions about these simple interest questions, or are we good with those? Can we move on? Okay, I'll take it that is we are good. And I have a whole list of these. Where did I put them? Here they are. Let's do compound interest. And you might think, well, what is the difference between simple interest and compound interest? Well, the first thing is that compound interest is actually much more realistic. Most banks do compound interest. Simple interest tends to be used when you buy cars and things, or if it's very short term, like a year or two, simple interest would work fine. But compound interest is a little bit different from that. And here is the big formula for the compound interest. A, the amount or the future value that your money is going to be. is P, the principal, what you start with, times 1 plus I. Sometimes we'll call it R over N if you want, but that's called the periodic interest rate, I, all raised to the power of a big capital N, and capital N is NT. Now that means actually that there are two versions of this formula depending on which textbook you look up. And there's a difference between capital N and baby N. So this formula and that formula are the same thing, right? I think, Tara, you were talking about Tuesday that some videos had one version of the formula and the other. That would be an example of that situation, right? You might say, well, why do I use this one and not that one? It's totally preference. If you end up using this formula, you might like it better because there's less things to remember, right? Because you only need to know P, R, N, and T. In this one here, you have a few more things that you need to remember, but the bottom line is that you get the same result. So how does compound interest work? Well, I'm going to give you a very simple story, and we're going to do compound interest. And I'm going to make it dead easy for me as well. 10% compound, right, compounded yearly. So what that means is that every year you get a 10% interest rate. So let's imagine that you started with $200. After 1 year, your new amount, if you went back to the bank and had a look at how much money was in there, wouldn't you get 10% of 200, which is $20? I'm doing that in my head, but 10% of 200 is $20. And now you would have $220 in the bank. Does that seem reasonable? I mean, I'm making the numbers easy to calculate. Now, doesn't that mean that you're now going to start the next year with $220 in your account? Right? You don't take in and out, you leave it there. And after the second year, let's see how much interest that's going to be. Well, if you take 220 and you multiply it by 10%, you get another $22. And now it's $242. Do you notice that you're adding $22 this time? Do you see how it's gone up a little bit more? Because aren't you getting interest on the interest? Which is kind of connected to what you were talking about, Katrina. You get the idea that it's not just the money you're putting in, but the money you're putting in is making interest, and that gets interest. It's like a snowball effect. I'll do one more. So you start the next year with $242, and at the end of year 3, you're going to have $242 times 10%, so that's another $24.20. $24.20. That's $286.20. Do you see how the increase every year, you get more and more money? Wouldn't it be kind of cool to follow this story for 10 years? And how do you do it? This formula here will tell you how much money you're going to have at any given number of years. So let's do 10 years. Which one do you want me to use? Do you want me to use the I and the N guy, or do you want me to use this one? I mean, it's a total preference thing. Do you like this one, or do you like this one?
I like the top one.
Okay, we'll go for the top one. So it's P, 1 plus I to the capital N. So I guess I'll have to write over here what P is. P is the money you start with, so it's 200. I is called the periodic interest rate. You get that by taking R and dividing it by little n. Now, R happens to be 10%. Oops. In this case, N is the number of payments you get in a year. Now, since this is compounded yearly, won't N just be 1? Right, I'm only getting paid once a year, so N is 1. So I ends up being 0.10. And capital N is how many payments per year times the number of years. Well, it's 1 payment a year times 10 years. So that's 10. So I'm going to have $200, 1 plus 0.1 raised to the power of 10 years. Let's show you how you do that on your calculator. 200 times a bracket 1 plus 0.10, close the brackets. To get the power, you use this funny little key here. It's called a caret. Little hack. Hit it to the power of 10 and you hit enter. It's $518 and if you round it off to the nearest penny, and 75 cents. Now that $200 has more than doubled, right? And that's just one $200. Can you imagine if you were really rich and you put 200, another 200 the next year on top of that, and then another 200 on top of that? So I'm just doing it every year, 200. But can you imagine you did $20 a week or $20 a month? Wouldn't that be $240 every year? Each one of them building on top of the other, like a snowball on top of a snowball. Really, really clever way of investing. Compound interest is your friend. I can be silly here. That's after 10 years. How much do you think that original 200 is going to be after 50 years? Right? So I just put it in the bank and I forgot about it. And then 50 years later, I find the bank card and I say, oh God, I've got money in the bank. I wonder how much it's worth. Okay. Do you think it's going to be in the thousands? You know, 2, 3, 4,000? Do you think it might be in the tens of thousands? Oh, higher. Okay. Let's find out. 200 times a bracket, 1 plus 0.10, close the bracket, raised to the power of 50 years. And the answer is a staggering $23,478.17. I think your parents might be right about that. Can you see how much money just one $200 would work for you? Okay, 10% is extremely high. But if you were putting it into some kind of stock exchange investment finance thing, that's the going rate. On average, the stock exchanging over the good and the bad still averages out about 10%. So that would be quite realistic. So pretty impressive, isn't it? Well, let's do a compound interest question where it's a little bit, well, let's pick one. That's what I'm kind of doing today, isn't it? So I'm going to pick question 8 and see if that's a good one. If not, I'll pick 9. Okay. My version of question 8 says find the future value. So when it says find the future value, they mean find A. And you start with, so that's P, with $250. The interest rate is 6 3/4%. And you're going to do it for 2 years. Is that the right one? That's not the right one. I apologize. You are going to find the future value. The numbers you start with are different. You're going to start with $576. And the interest rate is going to be 5.5%, and it's compounded quarterly. And you're going to do it for 4 years. Okay, before we start working on this question, I'm going for the sympathy vote here. You can't really tell, you've never met me in person probably, but I do wear glasses, so that is a clue. I'm virtually blind in my left eye. Can't see a damn thing out of it worth talking about. If I close my left eye, I can't even tell if you're a girl or a boy. That's how bad my eyes are. I know they're a human being, but I can't tell anything else. Right, so you can imagine how bad my left eye is. Now, if any of you have a really weak eye, you'll kind of sympathize with me here. A couple of the problems I have because of that is that I have very poor depth perception, because you kind of need 2 eyes to get good depth. So what does that mean for me? I have fun with door handles. I miss door handles. And sometimes I miss them by, grabbing air, and that's okay. But sometimes I miss them by hitting my hand off the door, which hurts. Parallel parking is an interesting experience with me. Do you know, you have to look in your mirror and see how close the car behind you is? Well, when you have no depth perception and looking at a mirror, it doesn't help very much, does it? And so I very often, I'm probably the safest parallel parker in the world, because when I do parallel parking, I think I'm going to hit the car, and I move very slowly. And then I get to the point where I think I'm going to hit it and I can't move anymore. So I open the door and I get out, and there's about 8 feet at the back. I mean, it's that far away. And then I'll go in and I'll sit down. And the minute I sit down, my brain says, don't pay attention to what you just did there. You're going to hit it. And so I crawl in very slowly. 2 more things. I've never seen a 3D movie. Do you know those movies where you wear the funny glasses? If I wear the funny glasses, I don't see 3D. So I have no idea what a 3D movie looks like. I think it might be cool. I can imagine it being cool. Or it could be, it's a gimmick. It's not really. Yeah, okay. And the last thing is, oh, thank you. I don't feel so bad that I'm probably never will see one. I've been to one, but I've never seen one. And the last one happened here. I will scan to a question, and then I'll come back, and then I'll go over and scan again. And what I tend to do is I'll start with one question, and then I'll finish with numbers from the second question. So you will get used to that in the future, that I may be saying I'm doing question 8, and then when you go and look at it, the beginning of it is question 8, but the other 2 numbers came from question 9. And that's quite a common mistake that I do. Did I get the sympathy vote there? Okay, back to this question then. Let's do the bottom one, just to show you can use either formula. A is P, 1 plus R over little n to the power of little n t. Now, one of the numbers that's missing here is little n, and it comes from here. Little n is how many payments in a year. If it's compounded quarterly, can you see that's going to be 4? Does that make sense? The most common ones are yearly, in which little n is 1, right? Quarterly, semi-annually would be 2. Monthly is very common. That would be 12. And when you're Bill Gates and really rich, daily. And when it's compounded daily, it's 365 payments. We'll pretend there's no leap years. Now, that might seem ridiculously big, that you could get paid interest every single day. Well, we don't get paid interest every single day, right? But Bill Gates does. Could you imagine $200 million in the bank? Even in one day, wouldn't that make a fair chunk of change? So he's got enough clout that the bank will give him whatever he wants. So if he wants it daily, they'll give it to him daily. You go to the bank and say, I want my money compounded quarterly, they'd laugh at you. Because unless you've got a lot of money, won't it be like half a penny? It wouldn't even be worth calculating. Right, back to this fella. $576. 1 plus the interest rate is a decimal, divided by little n, the number of payments per year, close the brackets, to the power of the number of payments per year times 4 years. Now, what makes this a little bit harder to do on your calculator is you have to be careful with brackets. So watch what I type in here and make sure you kind of follow the same routine. Bracket 1 plus 0.055 divided by 4, close the brackets. That's pretty obvious. Raised to the power. Put a bracket around it and call it 4 times 4. Now put enter in, and the final answer to the nearest cent is $716, and I think it rounds up closer to 67 cents. Are we good with that calculation? And do you know it's just a little bit clunky with the power? Some calculators, you don't need that bracket. You know, you might be doing a different calculator, in which case you could get away with not having that extra bracket. I just work on the assumption that if I'm not sure that I need a bracket, I give things brackets. I put little brackets around it. And I just realized I used a word. Shouldn't I have said you put parentheses around it or something? What do you call them in America again? I've forgotten. Are they parentheses?
Parentheses, yes.
Or are they brackets? Right. Are they brackets? Do you ever use word bracket? You're now going to start using the word bracket, aren't you?
It's like
that's
tomato and tomato. I think it's more of a preference.
There are
Okay,
ones
so-
that have like the arrow in the middle or whatever that I've always been told are brackets, and then those are parentheses. So,
Oh,
but
so
I don't think it really matters.
you're talking about the shape decides the name, right? I call them all brackets, regardless of what shape they are. Right?
We,
Kinda makes
we
my-
understood what you were saying, so it doesn't
See, that
matter
was
that
that
much.
right? Wasn't that context? You see what I mean about context? Right, back home, everything's called a bracket, right? Just a different, a different calculation of a different thing, right? So, what could I do next? That was 8. 9, pretty much the same. I won't do that. 13. Yeah, this is a good one. Right, I'm going to do my own version of question 13. And I believe question 14 as well. So 13 and 14 are pretty much the same kind of question. So we are going to start with some money. Okay, let's try and make it just class participation. How much money do you want to start with in this story? Give me a number.
18,000.
Okay, just means hitting buttons on a calculator, so it doesn't really matter to us. It's going to have an interest rate. I'm going to pick the interest rate. I'll make it 4%. Okay, and it's going to be compounded daily. And the time is going to be 4 years. How many days? 4 years and how many days? Pick a number for me for days.
11.
11 days. And we are going to find out the future value. How much $18,000 invested at 4% compounded daily would be worth at the end of 4 years and 11 days. Who cares why it's 11 days, but that's, you decided to take it out on your birthday, right? Whatever. Now, do you want me to use the top or the bottom this time?
Bottom one?
What do you want? Top, bottom one again, okay. So A, the amount that it's going to be worth is P, 1 interest rate over little n t. Now, 18,000 is good to go. I can use that. The interest rate is 4%. If it's compounded daily, doesn't that mean little n is 365? Would you agree? Compounded daily, it's 365.
Yes.
Okay. Now, little n is going to be awkward because I haven't done it yet. And t, sorry, little n is not awkward. Little n is 365. But t is going to be awkward. 4 years and 11 days. I need to figure out what that looks like as a decimal. 11 days divided by 365 is 4.030. I'm going to have to stop somewhere. How about 14, right? Are you comfortable that that's roughly what 11 days looks like as a decimal? I had to round it off or else I'd be writing all day. So it's going to be this guy times 0.03014. And now we're ready. 18,000 times, put a bracket, 1 plus 0.04 divided by 365, close the brackets, to the power of, I like a little bracket for safety, 365 times, and I put in the wrong number. I caught myself. Remember, it's 4 point, that guy. So it's 365 times 4.03014, and the answer ends up being 2,114 and what, 85 cents.
Is it 4 because it's 4% or 4 years?
It's 4 because it's 4 years, and that guy there is him.
I have a whole extra
That
number.
makes sense.
Did you do 1,800 or
Did I hit something?
18,000?
Oh, darn it in space. Look at my calculation.
I thought I was getting
What did
this,
I do?
And then I had the wrong number.
No, did you see what I just did there?
Yeah, you put 1,800.
That's not my eyesight. Yeah, but I'm going to go and fix that right now. And you're right, it just makes everything, I think, 10 times bigger. So 21,148, and I guess because I'm rounding, it's going to be 49 cents. Now, let's use that as a teaching moment. I got the answer, $2,114 and change. It's always a good idea to look at the question in context. I started with 18,000. After 4 years and a bit, the bank gave me 2,000 back. I should be kind of worried about that answer. Would you agree? Shouldn't I at least make some money? And then I would go and I'd say, what the heck did I do? And hopefully I would notice that I missed a zero. I could have missed that 4, couldn't I? Couldn't I have missed that 4 and put 0.0, and that would have given me a different wrong answer. So look at context, look at your answer and say, does that make sense in this story that that would happen? Right. Now I'm going to give you lot a question because it's connected to that one. I'm going to keep the P as 18,000. I'm going to keep the interest rate as 4%. I'm going to make the time a little bit easier, and it's going to be 5 years. But I'm going to change something else instead. There's going to be 3 versions of this question, and I want you to just randomly pick whatever one you like, and if you get it done, you know, pick another one. The first one is going to be compounded quarterly. The second one is going to be compounded daily. And the third one is semi-annually, which just means twice a year. Right. Find out how much my 18,000 would be worth in this story if it was compounded quarterly, daily, or semi-annually. And I'll give you 3 minutes to figure out which one you want and to do it. And the formula is either that one or that one. They both work. I'll put in this one again. It seems to be the one people like more. No pressure. Go for it.
Professor,
Yes.
I just got a message from Heather and she's asking to be let back into the meeting.
Yeah. Now
I caught that to about yeah. She got in. I caught it, but thank you.
Sorry about that. I accidentally closed the wrong button.
Oh, hey, I've done worse. You came in kind of in the middle of things, but we're trying to use this formula to calculate how much money would be worth in this storyline. So 18,000, 4%, 5 years, quarterly, daily, or semi-annually.
Okay.
And you're probably going to just have to, well, we'll pick one and see what we get. Oops. Okay, we're almost there. It's about 3 minutes. Okay, I'm just going to pick one of these 3 guys, and then hopefully you can tell me the other 2 answers, because hopefully someone's done each of the other 2. So do you want me to do a quarterly, a daily, or a semi-annually? Which one do you want me to do?
Quarterly.
Quarterly gets the job. Okay, so it's going to be 18,000. 1 plus the interest rate. Oh, thank you. That's a nice number. To the power of number of payments per year, which is 4 times what, 5 years. And on this calculator here, let's see if I get the right numbers for a change. 18,000 times a bracket 1 plus 0.04 divided by 4, close the brackets, raised to power, I'll just do that in my head, it's 20. And I get 21,963 and 42 cents. Does that look good? Good, okay. Now, the quarterly answer was $21,963.42. Did anybody do the daily one? Okay, give me the number for the daily one.
The daily one was 21,985.01 rounded.
Okay, does that look good for anybody else who did daily? Okay, anybody do the same annually? That's twice a year. Oh, we all done the first one then. Anybody?
I did semi-annual.
Do you have an answer for it if you did the semi-annually?
I got 21,115 and 6 cents.
Okay. Now, what might or might not surprise you is that these are different, even although everything else was the same. The only difference was when the interest was paid. So if it was paid daily, you got some money, you know, some interest every day. When it was done quarterly, you got this, and when it was done semi-annually. Notice that it was what, 21,100. If you did it quarterly, it's 21,963, and if you did it daily, it's a little bit small, but I'll take it.
Actually, the one
you notice
for
that you get more
the one for the
semi-annual.
I
Is
just
that a
figured
900?
that. Yeah, it should have been 21,941 and 89 cents. She forgot to exponent it. You have to stick it up, otherwise it'll give you a couple $100 difference because it doesn't do the operations properly.
Yeah, you have to put what I say, put the brackets in it. Right. Well, the gist of that is still true, isn't it? That if you get paid daily, compounded daily, you'll get more money at the end than if it's weekly or monthly. Can you see why banks probably only give you interest rate? Well, I think they do it every month, to be honest. I'm not sure. It might be every quarter. All interest rate in banks is compounded interest. That's the way it's done. So do you see why Bill Gates wants his stuff done daily? For the same interest rate, won't he make more money? And you know, that's the way of the world. If you've got money, you make more. Okay, so what would keep going in this? Well, the next kind of situation is that we want to have a story where we change the order of things a little bit, and I'll show you what I mean by that. Let's just say that we start with this formula, which is fine. Get that one. And I tell you this number, and I want you to find this number. Of course, I'll tell you everything else. So let's say the interest rate is still 4%, and you're going to get paid monthly, so there's 12 payments, right? And it's still going to be, let's say, 5 years, right? And now I would like to know what I need to start with, so that at the end of 5 years, being compounded monthly with an interest rate of 4%, what I need to start with, right? What P is, so that at the end I would be left with 100,000. So it's a little bit like that equation situation. So it's the same formula. but now I'm going to put 100,000 here. I don't know what that is because I'm trying to find it. 1 plus 4% compounded monthly, 12 times 5. It's the first time we've seen this calculation, and it might be a little bit distracting because there's a lot going on. So let me tell you what you should do first. Do you see that bracket with all the numbers in it, that big thing there? Isn't that a calculation that you can plug into your calculator and get a number for? So what you should do in these types of questions is simply find out what that is. So I'll do a bracket, 1 plus 0.04 divided by 12, close the brackets, raised to the power. Since that's 12 times 5, I'm just going to do that in my head and get 60. And I'm going to get P times 1.220, oh God, I'm going to be here all day, 996594. Right, I'm being very accurate. What do I need to do to both sides to get P? P times that is 100,000. What will I do to both sides to get P?
Divide
this.
by that 1.22,
Yeah,
et cetera,
that
et cetera.
thing, yeah, etc. Right, I'm just going to call it 1.22, etc. Right, so you know what I'm talking about. So I'm on the calculator here. I've got a horrible big decimal that I really don't want to type. Is there a way that I can get the calculator to help me? And the answer is yes. So what should I do here? I'm going to take 100,000. I'm going to go divide. And where my finger is pointing, bring up a little bit. There we go. See where my finger is pointing? There's a little blue guy called ANS. If you do blue button, it's answer. And answer is the last thing that was on the screen, the last answer. So that's so I don't need to type 1.220 blah, 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 blah forever. And when I hit enter, the answer I am coming up with is 81900 and 31 cents. So if you want to have $100,000 in the bank at the end of 5 years, and the interest rate is 4% compounded monthly, you will need to start with $81,900, and it will grow to 100,000 at the end of 5 years. Does that make sense how that question, how you would deal with that question? It's pretty much the same formula, right? But instead of trying to find A, we're trying to find P. It's not a very common question, but it is doable. Now, I want to, if that is okay, are we good with compound interest? You feel comfortable about it? Let's move on then.
I was going to ask on the question, it has
yes.
It has a every minute. So we're just plugging it in the same, but I know we didn't do it, and it always makes me nervous when I have to do one because they did the semi-annual, annual, monthly, daily, and then they have one that's every minute.
Yeah. Yeah, let me show you, because I'm sure everyone else who hits that question is probably going to have the same kind of scary thing going on here. Here is a version of that question, right? 13,000, there's the interest rate, 30 years, compounded quarterly, monthly. That one I'm a bit surprised about. I mean, 360 days in a year, come on. But if it says 360, we'll use 360. If you want to do it every minute, can you see that you're going to have 525,600? Right, so your little n in your calculation is going to be that number. There's two guys here that we haven't talked about, continuously and then simple. Simple we have. Isn't simple PRT and then add on the number that you started with. But compounded continuously, we're about to look at. That's the next topic. Let's show you how that works. Compounded continuously is not that one. Compounded continuously is this formula here, P e to the power of RT. There's only one version of that formula, really. Now, this guy E is interesting because it's actually a number. It's the number 2.7128, and it goes on forever. And it's on your calculator. Do you see where my finger is pointing here, where the division button is? If I do blue button, that guy, can you see there's an E there? And if I press enter, can you see the number I'm talking about? So what we do is we use the letter E to represent this very special number. It's quite unusual in math, but you have seen it before. Isn't pi just a number as well? So there's a few very special numbers in the universe in math that are so useful and so special, they get their own letter of the alphabet. So pi is one of them and E is the other. They're the two that you're probably most likely to ever see, right? Pi you've seen before and E is a new guy. So this is P times E to the power of RT. Now, what does compounded continuously mean? Well, can you imagine that you get paid daily? And Bill Gates says, hey, I've got 400 million in your bank account. I don't want paid daily. I want paid every minute, right? I want the interest every minute. Right, that's that 52,000 thing, right? And then the next guy says, nah, I've changed my mind. I want it every second. I want it every microsecond. Well, what does compounded continuously means? It means that you get paid virtually all the time, right? At any instant in time, there's a little bit of interest being made. A little bit hard to imagine that, but imagine that's what it is. Tara, you just had somebody come in and leave. Right, so let's give you a story. Someone put in $7,000. The interest rate that they got is 2%. They're going to have it for 5 years. And the key to look for here is compounded continuously. So if you ever see compounded continuously, will you remember that this is the formula that is associated with that question? So A, the amount you're going to have, is P E to the RT. So that's going to be 7,000 times E to the power of 0.02 times 5. So far, so good? Right, now, the devil is in the detail. How do I get my calculator to do this calculation? Right, let's show you how it works. 7,000 times. Now, it might not be very clear on this guy, but I'm going to do my best. Over here where my pen is pointing, do you see a little blue E with a little X? Here, you see it? On the hit the blue button and the LN button. Do you see it now goes E to the power of? Type in 0.02 times 5 and close the brackets. That's how you get this calculation onto your calculator. And when I hit enter, I now know how much money I'm going to have. 7736 point, I guess it's 20 cents then if you round it off. Are you happy with how you get this calculation now? You want to see another one?
Yes.
Okay, let's try another one. Let's see another one. Okay, I'm just randomly going to pick P's. Let's suppose that you had 12,000. Let's say the interest rate is 7.5%. And let's say it's for 4.5 years, right? So that would be 4.5 years. Then the amount that you're going to have in your bank account at the end of that 4.5 years is this formula, continuous Well, I should be saying compounded continuously. It has to say that or the question's not fair. So it's going to be 12,000. E, 7.5% is 0.075 times 4.5 years. Clear that one out of the way. Here goes. 12,000 times. To get e to the power, blue button, the ln. Blue button, ln. You see e to the power. 0.075 times 4.5 years. Close the brackets and enter. And in this case, 16,817. And if you round it off, it's 28 cents. We good? Compounded
Yes.
continuously. Use that guy. So let's show you one of the applications of compounded continuously. These are very often called inflation questions. Okay. Inflation is one of those things that sometimes doesn't really matter because it's not that important. It's not that different. Essentially what happens is from one year to the next, most items, not all of them, but most items go up in price. Some are seasonal and they go up in price just because it's the wrong time of year. But if we talk basic items that are the same all the time, like a car or a loaf of bread or a pint of milk, they tend to go up every year. And governments are very often very concerned about inflation when it gets out of hand. They don't mind a little inflation. It's actually, for an economy, it's quite healthy to have a little bit of inflation. So 2 or 3% is fine. It goes really, it'll destroy a country if it goes crazy. If any of you have been interested in history, can you remember the Weimar Republic in Germany after the First World War, right between the First and Second World War? Didn't they have a thing called hyperinflation, was the fancy name for it? And what happened in that poor country was that the inflation rate was a staggering 50% a day. So if something costs you $10 today, that same thing will cost you $15 tomorrow. And it's compound interest, right? It snowballs. So there were, towards the end, people had to use $1 billion mark notes, right? A piece of paper had to have 1 billion marks. It had to be worth a ridiculous amount just to be able to buy something. Money became essentially useless. And so you have to be careful with inflation. If you let it get out of your hand, it'll destroy you as a country. So we are going to look at some inflation questions. So I think they've got things that I can pick. Let's take a cup of coffee. Now, according to the question I'm looking at, this is question 15, a cup of coffee, they're saying is $3.75, you know. Depends if it's Starbucks or McDonald's, doesn't it? But let's say that's true. In this question, we're going to have an inflation rate. And that changes in each question. So I'm going to put in an inflation rate of 2%. It's a very low inflation rate. That's kind of what we're doing right now. That's going to change, I'm certain. And what we would like to know is, if the inflation rate stays as 2%, what will a cup of coffee cost me in 5 years? And then what would a cup of coffee cost me in 15 years, right? Same cup of coffee, but it will have increased in price. Okay. Now, the formula that we use is the one we already know. So if you ever see a question involving inflation, it's going to be compounded continuously. And I think that makes sense. Doesn't things go up in price at different times, right? it might go up tomorrow by 2 cents, right? And then something else goes up a week from now and it goes up 5 cents, right? So it kind of makes sense. So it's $3.75 e to the power of 0.02 times, let's do the 5-year one first. And if I do the 5-year one first, it's $3.75 times e to the power of 0.02 times 5 years. And it ends up being about $4.14. So what used to cost you 3 and a bit is now going to cost you 4 and a bit. And that's for 5 years. At the end of 5 years, that's what inflation will do. So if nothing changes right now and your coffee costs you $3.75, 5 years from now, that same cup of coffee is probably going to cost you $4 and a bit. Let's look at 15 years. What do you think 15 years is going to be? Do you think it might be $5? No. Do you think it might still be in the $4? What's your gut feeling? Higher. We've got a higher. Okay. Let's see what it's going to be. It's going to be $3.75 e to the 0.02, but now times 15 years. I can just bring that up and I can just change that to 15 years. And it made it to $5. Now, that is for a really healthy inflation rate. Any country in the world would be pleased with a 2% inflation rate. Let's do that same cup of coffee. Right? Cost you $3.75. But let's make the inflation rate 10%. And the inflation rate of 10% is not unrealistic. America, at certain times in your life, has had an inflation rate of double digits as well. I think it happened in the 70s. So it does happen from time to time. Let's just do the 15-year one this time. We won't do both. So it's going to cost me $3.75 e. Well, 10% is 0.10 times 15 years. In that country, right, this pretend country, 3.75 times e to the power of 0.1 times 15 years. Oh dear. $16.81. That's an expensive cup of coffee. And most of that is caused by the fact that when you have a 10% inflation rate, the reason you've got a 10% inflation rate is that your money is not worth that much, right, compared to the other currencies in the world, because you have to get your coffee from wherever the coffee is produced, right? I mean, some things you make at home and they don't increase as much, but other things you import and they increase by even more, right? So it averages out at 10%. So that's not good. So let's do poor Germany. And they had an inflation rate at least 1,000%. So if Germany today, thank goodness it's not true, but if Germany today had an inflation rate of 1,000%, we need to turn that guy into our R. Well, normally don't you get a decimal when you do R, right? 5% becomes 0.05. Do you know when you take this guy, you get a whole number? And that's because things are 10 times dearer than they were last year. So this is going to be 10 times 15 years. And let's see what that looks like. $3.75 times e to the power of 10 times 15. You might say, what on earth has happened here? Let me tell you what's happened. That e to the 65 means that. If any of you done science and you've done scientific, yeah. Can you see why Germany needed billion-dollar marks to pay for a coffee, right?
Yeah, with all the numbers on my calculator, I missed the E65 until you brought that up. I was like, whoa, wait, never mind.
Right.
That's a huge number.
Right. That is, in fact, it's really ridiculous. Now, what's going to happen to think? What do you think is going to happen to a country where your money is useless, right? Every single time that that's happened, the country that it's happened to, the hyperinflation ones, not the 10%, but you know, the really ridiculous ones, they've ended up having civil wars. In Germany's case, Hitler took power eventually. In other countries, there's civil wars, the country breaks down. I mean, the whole thing just falls apart on you. So we don't like inflation to be big. That's the bottom line. And now we have a way of predicting that. Are we happy with continuous? Do you like continuous? Thumbs up. Oh, where am I? I think I'm good. Yeah, I got half an hour. Good. I got a couple more guys I want to do, so let's see what I want to do them. Do I want to do 23 right now? Okay. Okay, let's do a present value story. We're talking compound interest again. So let's have a story where you've got money invested, it's 5%, and it's compounded monthly. And it's going to be for 4 years. And you want the money to be worth $50,000. What is P? So our question is, what do you need to start with to have $50,000 at the end of 4 years if it's compounded monthly? And the formula that you can use for this is that guy. So it's going to be 50,000 1 plus, I guess I should put some values in here. That guy there is going to be 0.05, agreed? Compounded monthly means that little n is going to be 12. That's going to be T, and obviously E is that. So we have an interest rate of 5%, compounded monthly, 12 times 4 years. So it's kind of going to be how to make the calculator work for us. And so here goes. I got 50,000 and I'm going to divide. I'll do a bracket, 1 plus 0.05 divided by 12, close the brackets, raise it to the power, and then put the little brackets, 12 times 4. If you don't want to do the little brackets for 12 times 4, do 12 times 4 in your head and just write 48. And the answer is that you would need to start with 40,953 to do that, right? 40,953.55. Tara, you're looking confused, like you're not getting that answer.
I just got a different answer, but I have it all. I'm looking at the calculator and I have everything entered correctly. So I'm just trying to figure out why it.
Okay, let's check it
Because I
out.
have 47,
50,000.
not. Yeah, 47,
Oh, well, that-
487. So I hit something wrong, but I have. So that's why I'm just trying to figure out what I did wrong. Ignore me
Okay.
for a minute.
Unless I could say it, I won't be able to help you. Right. So we're good with that or something similar. Right. I think for this next question using this, we should do a fun one. I want to be a millionaire. I think we all want to be a millionaire. So I want to have $1 million. And I'm going to pretend I'm 18. I'm definitely not 18. But I have got 50 years to make that happen. And I am going to get an interest rate of 6% compounded daily. Because I've figured out somebody who's going to do that for me. And my question is, how much money? So this isn't quite Kayla's thing. This is one lump sum, right? So your auntie gives you a big chunk of money. How much money would she need to give you, right? So if you just left it in the bank at 6% compounded daily, and you left it in the bank for 50 years when you retired, there'd be $1 million there. Do you think you need to put in a couple of 100,000? Maybe a little bit less? A little bit more? It's very hard to judge, isn't it? Well, let's find out. The amount that you would need to start with to end up with $1 million is $1 million on the top, 1 plus the interest rate daily, raised to the power of 365 times 50. So I have got 1 million, 1, 2, 3, 4, 5, 6 zeros, divided by a bracket, 1 plus 0.06 divided by 365, close the brackets, raised to the power of 365 times 50. Oh no, I want bracket 365 times 50. Right? Now I'm happy. Oh. Just put that on the screen. Just a touch less than 50,000. Now, 6.6% compounded daily. The compounded daily is not a big thing. You could probably get that if you were really, looking for an investment. Some company somewhere would do it for you, right? You'd get it somewhere. Provided you have to kind of sign a contract saying, I'm not going to touch it for 50 years. That's probably how you would get them to accept it. But you only need 50,000. Right? So doesn't seem so far away when you think of that way. Now, I don't know many people who just have a 50,000 lying about and are willing to put it away for 50 years and never go near it. I mean, that would take some self-control. But at least mathematically, if it was possible, wouldn't you be a millionaire at the end? Of course, in 50 years from now, won't $1 million not buy you quite as much as $1 million today? So you got to remember that we tend to think of the money in the future as if it's the same value as it is today. And the reason it's not is because of inflation. You know, the inflation makes everything expensive. Are we good with the present value formula? Do you feel comfortable about how that one works and for the stories that you use it for? If we're good, I'm going to move on. Are we good? This one here is, I'm calling it time calculation questions. Amelia seems to have been bumped out. Okay, we've got time. Good. Let's tell you what the story is before I go into this really ugly formula. You're going to be having an amount. So let's have a story. I would like to have $100,000. But I've only got right now, because my auntie likes me and she gave me it, $20,000. And I'm going to put it away. And I'm going to get 5% a year. And it's going to be compounded monthly. And I'm trying to find how long will it take for the 20,000 to become 100,000. So that's quite a complicated kind of question. Can you imagine? It's nice that there's a weird formula for doing it, but I've got 20. I want it to become 100,000. I'm willing to leave it alone until that happens. The place that I put it is 5%, and they're going to compound it monthly for me. How long is it going to take me? Right, that's essentially the puzzle. Right. Now, let's show you what the formula for it is. It's time, how long it's going to take me. It's a funny thing called ln of A, take away ln of P, all over little n, the ln. Now this is 1 plus I. If you don't like 1 plus I, and I don't think a lot of you do, can I call it 1 plus R over n? Because that seems to be the version that you like. It's 1 plus I, but we're using 1 plus R over n. Now let's see, do I know everything that I need? Okay, there's A, there's P, isn't R 0.05, and compounded monthly tells me little n is 12. So all the things that I need are here. Does anybody know or remember, because they may have seen it somewhere, what ln of, well, say 100,000 is? What's ln of a number? Anybody know what it is? Or what it's called? It's something to do with trees. The name is nothing else. It's a log. And it's got an N in it because it's sometimes called the natural log. And it's in our calculator. And thank goodness the calculator calls it ln. Do you see that button that we press to get the e to the power? It's right here, next to the 4. You see my finger pointing at it? Right there. Okay. Right, I'm going to do a different version than my normal calculator because this one's a little bit messy, and it might help if you see a big calculator version of it. So I'm going to risk technology here and see if we can get it. Are you all looking at a nice big version of my TI-84? I think it's a little bit clearer. I hope it is at least. The formula that we had here is ln of A and ln of P and all that stuff. Let me just show you how you calculate ln of something. ln of, say, 100,000. You see how you calculate it? You just LN, put in the number, enter. Now, the calculation I've got is a really ugly one. I guess I should come back and put in the numbers and then we'll go to this calculator straight after it. So I'm going to have to jump around just a little bit. Hopefully it won't throw you too much. Right. In my story then, right, this one here, it's going to be the natural log of 100,000, take away the natural log of 20,000, divided by little n, which is what, 12, the natural log of 1 plus r divided by little n. Right, so that's the calculation, right? That ugly thing there. That's the guy I'm now going to do on my calculator. So here we go. A bracket. You need the bracket. If you miss the bracket, it ain't going to be right. The natural log of 100,000. Close the bracket. Take away the natural log of 20,000.
For some reason, we just see you, not the what you're writing.
Ooh, I'm glad you told me. I'll try that again. Do you see it now?
Yeah.
Are you seeing a calculator? Okay, so I'll pretend I never did any of that and clear it out of the way, and I'll start from scratch. So a bracket, the natural log of 100,000, because that's what A is. Take away the natural log of P, which is 20,000. And then finish with a bracket. So look what it is. It's a bracket, the first natural log, take away the second natural log, bracket. Divided by, yeah, another bracket. And the bottom was 12 times the natural log of 1 plus the R value divided by 12. Close the brackets and then close it one more time and enter. And the answer that we get out of all of that is 32.26. I'm rounding off to 2 decimal places. So 32.26. Now, let's see what that looks like. That's time. But they don't want you to tell me that decimal. They want you to tell me how many years and how many days, right? We're back to that. Okay. Now, to get the days, don't you just take the 0.26 and multiply it by 365, and that's about 95 days. So if I wanted 20,000 to turn into 100,000 and it was compounded at 5% monthly, it would take me about 32 years for that to happen. That's a long way, isn't it? And what, 95 days? So 32 years and 3 months, roughly. Are we good? Right. Let's do the millionaire question then for our last, probably will be our last one for today. I would like to be a millionaire again. So I want to have $1 million. And my aunt likes me, but she doesn't like me that much. So she only gave me $15,000. And she said, leave me alone and don't come back till you're a millionaire. But I am lucky that I can get a 10% interest rate compounded monthly. So somehow or other, I managed to get a really good deal on the interest rate. And the question is, how long will it take? Okay, do you think I'm going to be alive at the end of that? Do you think 15,000 turning into $1 million will just take too long, right? 150 years, right? Nobody's going to survive it. Or do you think I might be able to make it? What do you think? Any gut feelings? Let's find out. The time, natural log of A, take away the natural log of P, divided by n times the natural log of 1 plus r over n. In this case, it's the natural log of 1,000,000. Take away the natural log of 15,000. Divided by 12 times the natural log of 1 plus 10% divided by 12. Okay, I'm ready to go. A bracket again. Natural log of 1,000,000. Take away natural log of 15,000. Finish by closing the bracket again. Divide, start a new bracket. 12 times the natural log of 1 plus 0.1 divided by 12. Close a couple of brackets. Answer. About 42.17 years, which is what, 42 years? And multiply what's left by 365 and about 62 days. What one of these numbers do you think is the main contributor to the fact that this is theoretically possible to do, right? You could live long enough for that to happen. Which one of these numbers is making that possible?
The interest rate?
Yeah. Do you know if you take that and you make it 5%, which is just half the number, right? It won't take you 84 years. It won't take you twice as long. The way compound interest works, because you're getting interest on interest on interest, is that it's a snowball. Like a little snowball turns into a really big one, right? And the size of the snowball increases according to this rate. And if you make this rate 2% or 5%, it takes an inordinate amount of time for that snowball to pick up speed and get big. In fact, in most of these situations, do you know the most amount of money is made in the last 5 years? Right, when you've already got, 500,000, right? It's going to become 550, then it's going to become 620, then it's going to become 700. 5 or so years, it'll